Hello, the objective of this video is to learn how to translate text into inequalities and graph them. Well, first we got to realize what inequalities are. Inequalities are equations, but instead of both sides being equal, there's a range of values which one side could have. And to show that range, we use these different symbols. This symbol is the less than symbol. This symbol is the greater than symbol. When you put the little lines underneath like this, it makes them less than or equal to, greater than or equal to. How do we know which one's which when we're looking at these things? Well, when you're reading from left to right, as you're reading from left to right, if you see the point first, that's the lesser side, so that's the less than symbol. If you see the big opening first, that's the greater than sign. And if you see a line underneath, whether it be the point or the mouth you open to see first, it's definitely going to have an or equal to on the end. Now I know some of you are going to have trouble seeing this table on the video. You may want to pause it, maybe try and find a larger screen to work with. For those of you that are in my class, we have copied this into our notes after the quiz. There is a PowerPoint available on Edline for you to get this from as well. All right. Word or phrase, if you have is less than or is fewer than, it indicates a less than symbol. If you have is greater than, is more than, or exceeds, those words indicate a greater than symbol. Is less than or equal to, is at most, maximum of blank or less, is no more than. These are key phrases for less than or equal to. Is greater than or equal to, is no less than, is at least a minimum of blank or more. Those are key words for greater than or equal to. And that's how you got to translate. When you see these phrases in word problems, you need to translate them to these symbols when you translate it to the algebraic expressions or inequalities, I should say. Algebraic inequalities. So here's a phrase. Bobby needs to place an order of $30 or more to get free shipping. $30 or more. We're going to start off with a variable x because we don't know how much his order is, do we? I could use O for order, but it looks too much like a zero, so I'm going to call x. Of $30 or more. This is that of blank or more, which was a key word for greater than or equal to 30. His order needs to be greater than or equal to 30 in order for him to get free shipping. That's how I translated this text into an inequality. Over here, the elevator will fall if the weight on board exceeds 2,025 pounds. Well, weight we don't know, let's call that W. And exceeds was a key word for less than. Was a key word for greater than. So the weight has to be greater than 2,025 pounds in order for it to fall. Not necessarily equal to it, but it has to be greater than the 2,025 pounds in order to fall. So that's how we translated that text into an inequality. Let's talk about graphing the inequalities. How do we graph an inequality? Well, first we start off with the fact that we're dealing with inequalities in one variable, so they're all going to be graphed on a number line. To graph them on a number line, here we have x is less than or equal to 5. I started off by drawing a nice straight line with arrows on both ends, because the number line does continue in both directions. I put a line right there in the middle, and I label it with the number that's part of the inequality. Now, I know some of you may have been told by teachers in the past, you have to have 0 on the number line. That's not true in order to show the graph of your inequality. It doesn't have to have 0 there. But what you should show is at least 2 places to the left and 2 places to the right, or vice versa if I can get my left and right, and label those numbers. In this direction, the numbers are going to get larger, so we have 6 and 7. In this direction, we have 4 and 3. Now we have a greater than or equal to 5. Do we want to include the 5 in that? Yeah, because the or equal to means that 5 is included. Is it going to start there? Yeah, it's going to start somewhere at 5. That's what that number indicates. That's our starting point. So in order to include it, I'm going to put a filled-in circle right here. This dot tells me I'm including this point right here, and I'm starting there. and less than. Now, to figure out which direction I'm going in, I got to figure out which of these numbers is going to make this inequality true. If I plug in a 4 for x, is 4 less than or equal to 5? Yes, so I do want to include the 4. I want to include the 3 too, because 3 is less than or equal to 5. So I want to include the numbers in that direction. Do I want to include the ones in that? 6, is 6 less than 5? Less or equal to 5? No. So I want to go in this direction. Now notice how I put the dot just above the line and drew my line with the arrow above, just above the number line there. You don't want to draw it 6 inches above, or really, because it's harder to tell where it starts with. Draw it just a hair's width above your number line that you're given. If you are given one, or you have to create one. Here we have x is less than 2, so we start with the same thing. Put a 2 in the middle. 2 marks to the right, 3, 4, 2 marks to the left, 1, 0. Less than, we're starting with a 2, but it's not less than or equal to. So how do I show that I'm starting at 2, but I'm not including that 2? To do that, mathematicians have decided to use an open circle to indicate that I'm starting here, but I'm not including that exact point. Less than, 1 is less than, 0 is less than, so I'm going to go in this direction. Notice how it also happens to match up with the direction that your inequality symbol is pointing. That is true as long as the variable is on the left-hand side. The true left-hand side, not the left I was talking about earlier. All right. Over here, we start with -3. So we put a mark in the middle, mark it as -3. Counting in this direction, we're actually going to go to -2, -1. In this direction, -4, -5. I'm going to put an open circle over the -3 because I'm not including the -3. I don't have an or equal to. I'm going to draw a line. Well, -4 is not greater than -3. -5 is not greater than -3. Remember, the larger the negative value, the smaller it actually is. So we're going to -2, -1. 100 is definitely bigger than -3. And we're looking for the stuff that's greater than -3. So we want to go in that direction, and we show that by putting an arrow in this direction. Everything in that direction, every value in that direction is a solution to this inequality. All right, then we go down to this problem here. We have x is greater than or equal to -37. Put a number right here in the middle, 37. This time, I don't know, maybe I want to count up by 3s instead. Can I do that? Sure. This will be -34. This would be -31. Here would be -30, this would be -40. And this would be -43. You don't have to count by ones. That might be a helpful thing to remember later when we're graphing more than one spot in the number line. All right, greater than or equal to, which means I do want to include that point, so I'm going to put it in a filled-in circle. I'm including that point filled in a circle. Greater than, that every number in that direction is going to be greater than this, so I want to go in that direction, towards the positives. All right, let's take a look and try some on our own here. Remember, in order to learn math, the best way is to do math. Take a moment, pause the video, give these a try. Welcome back. All right, we have a spot in the middle here, that's 8. 2 marks to the side, 9, 10. 2 marks to this side, 7, 6. Less than, not or equal to, so it's an open circle. Less than means we're going to go in this direction. We're going to get towards the lower numbers, which is also indicated by the fact that the arrow is pointing in that direction. All right, that's the graph to that one. Number 2, we put a 4 here. 5, 6, 3, 2. Greater than or equal to. The or equal to means we have a filled-in circle. Remember, be very careful when filling in those circles. I've seen students that, when doing an open circle or doing something like this, they kind of went like through like that. It looks like a filled-in circle. Or, it's hard to tell whether it's filled in or not. Make sure it's very clear that it's filled in or not filled in. Greater than, going in this direction, there's our graph. See you in class. Hope this helped.